Laboratory of Modern Technologies. His task includes the fact that in this laboratory we create models. A model is a question that an experimenter asks nature, and depending on his answer, he receives an answer, and depending on this answer, he determines how close it is to the essential features of the phenomena of nature itself. The models include research and scientific research. We mainly proceed from physical and mathematical research. The laboratory also includes design developments, the creation of various kinds of drawings and design models. It includes the development of special design work, includes experimentation, testing, creation of models and prototypes. If you mistake by 1 unit, as suggested in the literature, when creating a model at the study level, you could be off by 1,000 times more when you're releasing it in bulk. Therefore, the main goal of the task is to prepare for industrial testing, for mass production, models that correspond to introduction and implementation. We submitted our invention for international examination, received a positive search and a positive conclusion on scientific novelty, inventive step and industrial applicability. Then we received patents from Georgia, Germany, and we filed with the European Patent Office of the USA, India, China and Japan. According to the latest data, the European Patent Office also issued a search conclusion in category A. After this and along with this, we began to create models for the braking device, which is used to slow down the vehicle, the movement of the vehicle. We made 9 models, we tested 7 models. Next, we developed one model, which is very important, which works on the 3-in-1 principle. It should be noted that, for example, when braking, people have learned to walk, slow down and stop. Living organisms do the same. From birth they have 3 functions, 3-in-1. This is slowing down, stopping and stabilizing speed. In the mechanical mechanisms that are being developed today, it's not that there is no deceleration, but at the same time they are weak in the retarder or when using brake disc pads, they block the disc to varying degrees. In reality there is no slowdown. It's the same with electric motors. There you even have to use a probe, which must strictly maintain a 0.05 mm distance so that there is no probe and it grabs right away. It's not slowing down, it's engagement. In today's machinery there is virtually no option for mechanical braking devices to slow down the vehicle. We have it 3-in-1. It slows down, stops, and stabilizes the speed. No ABS system is needed here, because the person adjusts the pedals himself. Much better than the ABS unit that is used, the computer unit is the human brain. In addition, when using ABS, you have to use different chips that monitor the speed of rotation of the shaft, disc, wheel, and so on. Moreover, all this is located in the foot part, the wheelbase part. It turns out that if moisture, dirt, etc. gets there, the ABS system will not work. The ABS system itself is called anti-lock braking system. This means that the brake pads block the disc, but with us it doesn't block. It slows down and stops. There is such a concept as a sudden stop. It is a wrong concept. You can quickly make a partition and stop it, but we introduced the concept of a quick stop, that is, with a given negative acceleration. Nature does not like sudden movements, nor does it like sudden stops. Judge for yourself. When a person runs, he does not stop abruptly, he stops quickly, reducing his speed. These are the models we have developed, unique models. Based on these models, we carried out industrial tests of 3 of our braking devices with different types of elastic elements on one axis in the factory, and also tested a traditional braking mechanism based on dry sliding friction. We do not have dry sliding friction. We do not have such violence of one part over another. In fact, what we see today, the brake mechanism, is the same as the grinder. One part is stationary, and the other part rotates. They touch and know that they are one another. At the same time, all sorts of harmful elements are released, such as arsenic, antimony, copper, iron, and very dangerous asbestos, which causes liver and lung cancer. According to the conclusion of the British company, Mission Analytic, the emissions from our braking systems are 1,000 times worse in comparison with the exhaust fumes of a car, and they even conducted research. They checked it and called it almost a black hole. So we are coming out of this black hole, so to speak, and we have solved this problem. We have no emissions, we decelerate at the required speed, and accelerate more precisely. This is how we do it. So there is a significant difference here. Imagine, a person uses muscles and joints when braking. If we liken these joints to almost a rolling support, and let's say compare the muscles to a spring, then we use these two elements of elastic hinges when braking. We don't have dry sliding friction, which is very important, I'll tell you. Because, as I said, it pollutes the atmosphere, especially if it is located under the foot part. It gets destroyed, sometimes to a greater extent by infecting microorganisms in ecological niches and the environment. It also affects animals, dogs, children and others who are closer to the ground. Therefore, dry sliding friction is detrimental. For 5,500 years, the principle of braking has not undergone any significant changes. In my opinion, of all, say, inventions taken, inhibition due to whereby one object in contact with another object is the most detrimental, as an invention, as an approach, and so on. We do not have dry sliding friction. We use elastic elements rigidly fixed to the disc or to the shaft on the shaft or on the disc, which are covered by the bearing, and at one end the elastic elements are rigidly fixed to the disc, with the other ends free. They are adjacent to the inner end of the bearing. And when they almost begin to move and come into contact with these elastic elements, they begin to deform according to Hooke's law and create a resistance force to the rotating movement. Depending on how hard you press the pedal, the rate of change of speed, that is, negative acceleration, depends on this. Our principle is that we do not use dry sliding friction, but use the change in potential energy, the internal energy of the elastic element. This is our principle. Since the traditional brake mechanism engages and locks the brake disc due to dry sliding friction, it will naturally work jerkily. But these jerks somehow try to smooth out the ABS system. But even so, when the car is traveling at high speed, it stops in various ways such as jerking and locking. That is, its internal temperature rises. I want to note this in parallel. This is a very important point. When the temperature of the brake disc increases, the pads are transferred. They do not burn, as a rule, but they heat up. ABS and other high-temperature elements are used for the pads. Something like 25 components, 250 mixtures. But they still transfer heat to the cylindrical piston that is in the cylinder and pushes the pads to this disc. It overheats, expands and tilts, and does not provide the opportunity for further movement. Regardless of whether the oil flows down, it still jams there. As they say, the brakes jam. In reality it is, say, the brake pads, the discs jam. In general, we can't even have fundamental ones. In our case, each subsequent spring, which rotates together with the inner ring of the bearing, is deformed neatly, sequentially, depending on the frequency of these, say, elastic properties. It can be specifically adjusted for any car, in order so that it stops smoothly. Because of this, we don't have squeaks. Conventional brake systems, if you notice, have squeaks. Noise occurs there. There are also quite a lot of undesirable effects, overheating and so on. We don't have squeaks. Our temperature is maximum when we stop. Our temperature rises by 50 to 60 degrees. For conventional brake systems, there are world tests of Bugatti. If you look, Brembo and so on, Their brake disc reaches a temperature of about 1000 degrees. We do not have such temperatures. Returning to your question about balancing, when everything is done smoothly and quickly, the desired balancing is always achieved, in contrast to the traditional mechanism, which with jerks and overheating is fundamentally impossible to achieve the balancing that you talked about. The systems that we have been selecting for 19 years, even before patenting, we had problems related primarily to interchangeability, which we spent 5 to 6 years on. Due to the fact that, on the one hand, the inconvenience was caused by the issue of time, labor costs and interchangeability. On the other hand, those systems that were grinding in, they caused thermal gradients, temperature gradients. We have solved all these problems. Our device allows us to solve such problems because it is significantly different. Why am I talking? While maintaining the previous model, attempts to change by some extensive methods, to change the essential features of a particular model, are an untenable task. We have a new model, and in this new model we were able to solve this problem. The main problem is temperature gradients, and the second is the problem of interchangeability. Now we can replace them in almost the same amount of time as replacing disks. A traditional retarder is generally a retarder. It allows you to slow down without using the main braking system, especially it is used in mountainous conditions, on long slopes for large vehicles, buses, trains, etc. It has two principles: hydraulic and electromagnetic. Preference is given to hydraulic. Its essence is that braking and deceleration occurs, by the way, without blocking, as usual, as I told you, the brake pads. This occurs due to internal friction of the oil. One is a reverse version, similar to the torque converter used in cow transmissions. Here it is in reverse. Let's say our starter is located in one blade, and in a movable rotating shaft in the other blade. And when this space is enriched with oil, then due to this internal friction it begins to slow it down. What's the problem? It correlates on a very small scale, 5 to 10%, 15% does not slow down anymore as a rule. And at the same time there is one problem for the retarder. If in order to increase, say, the braking torque, which is created due to the density of internal friction of the oil, then its viscosity and density have to be increased. When density increases, viscosity increases. An increase in viscosity leads to phenomena such as sticking, gluing, and so on. And, in the end, the retarder stops working. But then, if, say, we go in the direction of decreasing density, increasing the pressure of steam oil, then its, say, adhesion decreases. Between these two problems, based on the immediate physical properties of using the oil, the possibility of a retarder is limited. Unlike electromagnetic and hydraulic retarder, we use mechanical retarder. Its action is based precisely on the principle of operation of the braking device. In addition to the fact that our retarder will slow down the movement, it will also be able to stabilize the speed, which is very important on a slope, when we have vehicles moving and descending for a long period of time. In no way, for 5,500 years there have been different technologies, there have been scientists, there have been large companies that are intensively engaged in all sorts of new technologies, developments, and so on. I want to say in this regard, the lack of an idea, even people didn't pay attention. The main thing in physics is observation. The fact that people did not pay attention to how a person himself stops. He does not use pads, no dry sliding friction, even joints. If the hydrocyanic fluid decreases, our joints hurt like this, the scabbard especially like this or in other connecting nodes of the body. Therefore, it was not related to the development of new technologies. A question may arise to you, then, at the time, 5,500 years ago, during the time of Mesopotamia. Could they have done this? There was an idea here, yes. Everything that was technologically necessary was present there. As we say, here we will allow elastic elements and rolling bearings. There at that time 9,500 years ago there were bows, arrows, elastic elements were bows. Tubes could be made, some kind of separate rollers or tubes from wood. There was also enough oil, if you want from a cow, if you want from natural resources. There were resources right there on the surface, even without it. We have a diagram for this. We will show you this diagram. In those days they could make a sighting sliding braking device. Recently, answering a question from one of the EU representatives, I sent an answer of this nature. If the European Union comes up with this proposal and initiates it, then in the person of the European Union the entire world community will receive 1,000 times harmless exhaust gas ratio, will receive harmless technology. No asbestos or any other harmful elements will be released. In addition to everything, we draw attention to the fact that along with reliability, efficiency, if, for example, Brenberg is now producing carbon fiber there and so on, costing $33,000 per set, with us they will cost a maximum of $1,500. And if they last 200 to 300,000 kilometers, as they say, then ours will last 1,000,000 kilometers. As long as the bearings last, our braking devices will last, no matter where we use them. In addition to this reliability, it provides comfort. I especially want to note that, for example, for elevators and cranes, 3 types of braking are used, 3 functions, say, holding, emergency braking and braking as such. We have all 3 functions in one. It decelerates at a given acceleration. Increase safety and comfort. And the operator does not need to be distracted by different types of braking and so on. It operates with one pedal and one brake control. That's why we ensure both safety and comfort in all vehicles. This means that the main industry is mechanical engineering. Since there are 3 billion vehicles in the world, they emit millions of tons of particles not in a gaseous state. Say, not in a gaseous state, as usual, exhaust gases from a car, but namely solid particles. These particulate matter, as I said, are iron, antimony, arsenic, asbestos, which causes liver cancer, and in general they weaken the body's immune system, but cause irreparable harm to the ecological niches surrounding people. For example, cows eat this grass and the milk that we and ours use. It's all very harmful. Therefore, first of all, road transport will be neutralized. As the British company Mission Analytic points out, it is 1,000 times more harmful than exhaust fumes. We are removing this harm 1,000 times over, protecting the human environment and their environment. Then the issue of safety is also resolved at the same time, because you yourself regulate, say, how fast or slow you need to drive or stop. Then the vehicles, that's how things are. In addition to vehicles, these braking devices can be used in various elevator equipment, when the elevator descends and ascends, so that there is no tension in the cables due to blocking by the existing brake systems. He will stop them smoothly, move them smoothly, and so on. This can also be used in all types of transport systems, from bicycles to passenger aircraft, including cargo vehicles, which on mountain slopes require a long time for speed stabilization. We have a separately developed speed stabilizer, but it can be used on the basis of a braking device. We have separate developments for each type of transport systems for bicycles, motorcycles, scooters, small cars, regular cars, premium cars, cargo buses, train vehicles, 5-axle heavy vehicles and passenger aircraft. This is separate. Further, for elevators, for cranes, for medical equipment, for numerically controlled machines, where high accuracy and optimal speed are required for bringing, say, the spindle, the head of this machine to the parts and removing it from it. These directions will be used effectively, harmlessly and comfortably. The main thing is that this comfort will be great for elevators. Also for passenger aircraft we have separate know-how for passenger aircraft based on our patent. They will be used everywhere in all types where comfort, safety, and so on are required. Friction is most common in machine mechanisms and equipment. These are the issues we are addressing in this direction. We do not take one braking device as a basis to test it and so on. We're coming from a more global perspective, given that this is a 1,000-year-old problem, although people don't talk about it, but it actually remains just as problematic. We first created 9 models with different elastic elements and tested them repeatedly. First, we did a study and selected the properties of the elastic element specifically. For example, for some models we used spring steel that complied with the interstate standard. For others we used plastic. For the third we used special fiber rubber. We check other elements based on their properties and their size. Then we carry out tests on the prototype. And we carry out all tests, especially for the latest models and prototypes, in comparison with traditional ones. We make 2-in-1 comparisons, both traditional braking and our braking. Then we move on to testing industrial prototypes. There we concentrate our 3 units on one shaft with cylindrical, cone-shaped springs, and special fiber rubber. This is a special rubber that can be mass-produced and has unique elastic properties. And we compare 4 of our devices on the shaft, 3 of ours with new properties and traditional ones. And we test everything on the same shaft, how it slows down, how and so on. For example, we discovered and were convinced that when braking with a disc it locks instantly, and when braking with our device it does not slow down sharply, but quickly. It slows down smoothly, without squeaking, without anything. When, as in conventional brake systems, there is creaking and so on. We are conducting such research and preparing, as I said, a real model. We take into account the research, then especially first design work, ordinary detailing, experiments, then special design work, experiments. Then we move on to testing the model, then we move on to testing prototypes, and then we move on to testing industrial samples. We have an official auto test from the GMG company, which conducted the tests, and we also have a conclusion from the National Academy of Sciences regarding our invention and recommended for implementation in practice. These are the tests we carry out as we should. It's not just the same thing, like Brem and other companies. Thousands of hours of testing are carried out on one pad in a pair. Demanding tests. 300,000 kilometers, let's say, mileage, is almost 8 times around the globe. Tests have been carried out for several years. We have 10 to 15 years. Moreover, everything that is used there, elastic elements, springs, bearings, they have all been tested separately for a long time, and we do not think this is so important, since they have already been determined. The main thing for us is to solve the issue of interchangeability with the correct design. That's what we decided. It should also be noted that, unlike today's mechanisms, which have to be ordered somewhere, some companies make them, then supply them to automobile companies. We will provide recommendations and specific drawings, and so on, for automobile companies. They themselves can install braking devices on their vehicle in accordance with the dimensions, inertial properties of their car, and so on. Therefore, this is also an important point. Motorists can provide the braking of their car themselves. Technology itself determines the longevity of its impact on society. I think so. If it hasn't happened in 5,500 years and people use it, it somehow correlates with the technology, the innate technology of living organisms. Not completely, but to a certain extent, even to a large extent. If we are talking about slowing down, stabilizing speed, stopping this or that object, a living object and, say, a mechanical object, they somehow correlate. That's why I think so. I can't say how long society will live. Well, as long as it is alive, I hope it will use this technology. And most importantly, it has such elements, some parameters, that it will be harmless, reliable, and comfortable. Therefore, whoever needs it will use it as much as necessary.